Okay, we're going to be looking at solving inequalities here by isolating our variable. So if you take a look at this one, this is off of worksheet 5.4. Our first step here is we want to isolate our variable, okay, by subtracting 9 on both sides. So we're going to subtract 9 here, subtract 9 here. That gets rid of this 9. Okay, so P is greater than or equal to 4. Okay, and that's the correct answer there. All right, let's look at another one. Here's another one. This one has a little different sign. This is a greater than or equal to sign. If there's a line underneath, that includes equal to. And our variable's over on the right side. So this one has a few other challenges to it. Okay, we want to get rid of 7, so we want to subtract 7 because it's a positive 7. All right, these cancel. So we have x, our same symbol we bring down. And here, negative 12 minus 7 is negative 19. Now, we don't want our variable over here. We want to move it over to this side. Okay, so we have to switch our sign around. Okay, so if negative 19 is greater than or equal to x, well then x is less than or equal to negative 19. It's kind of like reading it backwards. You know, if we read it this way, we'd be hitting the sign closed up less than, you know, so that's one way that might help to see how you flip that. Okay, here's another one, and this is where it's easy to get mixed up. Okay, we have a negative number here, and any time that we divide both sides or multiply both sides by a negative number, we need to switch to inequality symbol. So if we divide by negative 8, and we go over here and we divide by negative 8, these cancel, but we have to switch this inequality symbol, and I'm going to show you why in a second here. So this ends up being less than, in this case, this should be a negative 2. We divided both sides by negative 8 to get x is less than negative 2. Now, why do we have to switch this sign? Here's the reason. If you think of it this way, if you have a negative 3 is less than positive 3, I think everybody would agree. Okay? Now, if I divide both of these by a negative number, say I divide both of them by negative 3, watch what happens. Negative divided by a negative is a positive here. This comes out to 1. Okay, this over here comes out to negative 1. And you know that 1 is not less than negative 1, it has to be switched. Okay? And the same thing applies if you multiply both sides, okay, by a negative number. So if I multiply this side by, say, negative 2, and I multiply this side by negative 2, watch what happens. This becomes 6. This over here becomes negative 6. This sign no longer is true. It's not less than. 6 is not less than negative 6. It's the opposite. The sign has to be switched. Okay? So the idea behind that is if you multiply or divide both sides by a negative number, you have to switch the inequality symbol around. Hopefully that helped there. Okay, let's continue on. Here is another problem that we'll look at. Okay, so I'm going to divide it into two sides. I got to divide by 4, divide by 4. Okay, these cancel. Okay, so you get a, and over here we get negative 3. Okay, now we don't have to switch the sign because we divided by a positive number, but we do have to switch this around. Okay, we want the variable over on this side. So a is going to be greater than or equal to negative 3. Okay, we want the variable on the left side. Now this, if we were graphing this, okay, this would be a darkened circle at negative 3 with an arrow going to the right. This tells you which way your arrow should be going when you're graphing on a number line. And if it's greater than or equal to, that's a darkened oval. If it's equal to as well, then you darken the oval. If it's just a greater than symbol, it's an open oval. Okay. All right. Here's a tricky one here. We're going to divide both sides by negative 2. Okay, so we got to switch our sign around. So we're left with k. We got to switch our sign to negative 7. Now we got to switch it back because we have a variable on the wrong side. Okay, so it ends up actually being k is greater than negative 7. If we were graphing this on a number line, it's an open circle at negative 7, okay, and your arrow then goes to the right the same way that our inequality symbol is pointing. Okay, let's see if I got another one here. All right, here's another one. Okay, I have to multiply now both sides by negative 2. Once again, that same rule applies for flipping our inequality symbol if we're multiplying or dividing by a negative number. These cancel. We got to flip our sign. Okay, now we got to go back because our variable's on the wrong side. So we're putting the sign back to greater than. Okay, there would be our answer to that problem. Kind of tricky. Now, if we're graphing this, it's an open circle at negative 10. Open circle, because it doesn't have the equal to, and an arrow going to the right. All right, a couple more. All right, here's another one. All right, I'm going to multiply both sides by negative 3. Okay, so this cancels, but I multiplied by a negative number, so I got to switch my sign around, and there would be my answer. A negative times a negative is a positive. Darken circle at 12 when we graph it. Darken the oval because it includes equal to, and an arrow going to the right, same way our inequality symbol is pointing. All right, and the last one. Here now we have to get rid of negative 1/2. We get rid of a fraction by multiplying by its reciprocal. So we're going to multiply by negative 2/1. We're multiplying by the reciprocal. Okay, we do the same thing over here, multiply by negative 2/1. Now we just multiplied both sides by a negative number, so once again our sign has to be turned around. Okay, so I got to make sure I remember to do that. These cancel, so we're left with x is greater than or equal to, in this case it's going to be positive 12, not negative 12. I started to put a negative there. So our answer is x is greater than or equal to positive 12. Darken circle at 12, oval going to the right, same way our sign is pointing.